In previous lessons, you learned that when outcomes in a sample space are equally likely, the probability of an event is the number of outcomes in the event divided by the number of outcomes in the sample space. However, when the outcomes in the sample space are not equally likely, we need to take a different approach. Let's look at example 1 to see what we're going to do when these are not equally likely. So example 1, when Jenna goes to the farmer's market, she usually buys bananas. The number of bananas she might buy and their probabilities are shown in the table below. So the probability of her buying 0 bananas would be 0.1 or 10%. 1 banana would be 10%. 2 bananas, 10%. 3 bananas, 20%. 4 bananas, 20%. And 5 bananas, 30%. So our first question says, what is the probability that Jenna buys exactly 3 bananas? So if we look at our table and go to 3 bananas, the probability that she will buy 3 bananas is 0.2, or you could write that as 20%. Okay, the next question, what is the probability that Jenna does not buy any bananas? So that would mean that she buys 0. So we're going to go to our table. So 0 bananas is 0.1 or 1/10. Or that would be a 10% probability. Okay, so our next question says, what is the probability that Jenna buys more than 3 bananas? So this is where we're going to start to combine some probabilities. So she could buy 4 bananas or 5 bananas. So I'm going to go back to my table and then list out those probabilities. So for 4 bananas, it was 2/10 or 20%. So I'm going to put 0.2. Oh, can't see that marker very well. Let's try this one, see if it's better. There we go, that's better. And then for 5 bananas, it was 0.3. So in order to find what this total probability is, we're just going to add these two probabilities together. So we're going to go 0.2 plus 0.3, which gives us 0.5, or 50%. So she has a 50% chance of buying more than 3 bananas. Okay, what is the probability that Jenna buys at least 3 bananas? So this time we're including the 3 bananas as well. So she could buy 3 bananas, 4 bananas, or 5 bananas. All right, so we know from our previous problem already that the 4 was 0.2 and the 5 was 0.3. So I'm going to go back to my table, and 3 was 0.2. So we're going to combine all of these probabilities together. All right, so there's my 0.5 that we found in the previous problem. So we're going to add to it the 0.2. So we get a total of 0.7, which would be 70%. All right, and our last question here says, what is the probability that Jenna does not buy exactly 3 bananas? So she does not buy exactly 3 bananas. So let's look at our table again. So if we combine all of these probabilities, this would equal 1. So we have 3, 4, 5, 6, 7, 8, 9, 10. So that would be like 100% of all of our probability. So we're looking at the probabilities of all of them except for this exactly 3. So you could do this a couple of ways. You could first add up all of the other probabilities, or we could take that whole 100% and take out just the amount that of the probability that goes with our number of bananas. So for this one, we're going to say 1, and then we're going to subtract out the probability of buying 3 bananas, so the 0.2. And that would give us 0.8, or 80%. So a note that we want to make sure that we look at here is that notice that the sum of all the probabilities in the table is one whole, or 100%. This is always true. When we add up the probabilities of all of our possible outcomes, the result is always 1. So taking 1 and subtracting the probability of the event, that gives us the probabilities of something not occurring, like what we did here. So subtracting out the something that does not occur gives us the probability of everything else that could occur.